Get Certified Together program is created by Technocofe, your free online knowledge sharing website, based out in London.
In whole year, if it's down for more than 5 hours, then we will be bring that application up within 5 hours, and if we are not able to bring that up within 5 hours, we'll be liable to pay you some kind of fine, or there will be some kind of cost associated with it. So that's SLA, or service level agreement. This is just a generic term. It have a lot of course nitties and gritties. You can understand, you can read more about it. If you are already into the tech field, then you must have.
If you're a podcast host, listen up, this one's for you. My name is Allie Jackson. I'm the host of Finding Mr. Height, a dating and relationship podcast that I've been doing for 4 years now, sharing my positive and practical approach to dating that's built on my own life experience. And I wanted to share another experience that I've had, my secret behind monetizing my show. It's called Red Circle, and I was just telling my colleague about how much I love their platform. With Red Circle, not only am I getting a seamless hosting experience, but I also love the support I receive in ad sales. It's not just typical ad sales either. It's targeted opportunities based on my show and my life. And the platform is super simple. You just set your preferences and Red Circle matches you with sponsors that align with your show. You can vet every opportunity and their platform gives you great analytics. More recently too, my Red Circle team has brought me opportunities outside of my podcast on social media to really augment the podcast partnerships, bring them full circle. I just can't recommend them enough. If you want to give it a try, go to redcircle.com to get your free trial. That's redcircle.com for a free trial.
Hey everyone, welcome to another episode of Get Certified Together series. This is episode number 43 I'm recording today, and I'm recording this just next to the Christmas day. So we had some fun-filled celebration. I had decorated my house. Of course, we got a Christmas tree. I got the fake one, to be honest, but if you got the real one, if you are really celebrating with the real tree and all the full-fledged decoration with a makeover of Santa Claus, then I really hope that you guys are having a great time. If you are not into the Christmas celebration, then still, at least this is a holiday time and you can have fun. Even though if you're not celebrating Christmas, you can still have fun with your family, with your friends. If you are not having holiday period at all, because I know in some part of the world there is no Christmas holidays. I've been to that situation where we hardly had, I think, 2 or even 1 day of Christmas holidays. It's not like it's a worldwide international phenomena. We have some places where we don't have like those long period of Christmas holidays and full-fledged 2 weeks. If you are from that part of the world, then that's completely fine. You can still have some kind of celebration, and the most important part is you have to gear up for the next year. We talked about failed resolution in the last week episode. I shared one myself where for me, I really tried to do something for my website and I was not able to do it. I am writing the resolution again. Hopefully I'll be doing something this time. I don't want to fail back to back in the 2 years, but still, even if I fail again, then it's nothing to be feel bad about, because we can still get on our feet. We can still try to do something at least, and still try to put some kind of efforts towards growing ourselves and towards building our knowledge, toward building our own personality. So that's all we can try from our side. Of course, the outside world, the political and environmental side is getting messier, if you know what I mean. We have a lot of wars, we have a lot of bad situation going in and around in different parts of the world. I pray for the peacetime, and it was funny because I was reading it somewhere in one of the book that we actually kind of lived the most peaceful time of the humanity from 1950s to 1990s. We were in kind of like the most peaceful time in the humanity since we started having this recorded history. It's quite strange, right? Because we are kind of used to living in the peaceful world, but actually we are living in a peaceful society for just 40-50 years. We are always in the wars and there was always conflicts everywhere. So it feels sad because it's kind of like part of human brain, a part of our nature as a whole, that we always try to find conflicts in the situation where otherwise we could have a peaceful resolutions as well. I'm not not that political in that sense. I don't want to go deep into that. I don't have much knowledge around all the conflicts which are ongoing, but of course we can always pray for the peaceful time, and if really we can achieve the peace and think about more towards like progressive society where we have more concerns around the real problems, which is around environment and which is around making and building a better world for our next generation. I'm not sure whether people are really into that, but yeah, that's something we should have to look into. Enough on all of that. Let's jump into the cloud security operations. It's quite a big shift, right, from politics to cloud security operation, but yeah, that's how we do in the Get Certified Together series. In today's episode, we will be covering cloud security operations domain 5's section 5.3. Remember, I told you that this domain is really big and they have a lot of subtopics which are actually repetitive. Even in the today's episode, you will find that some of the topics will be repetitive and some of the topics are already covered in the previous week's episodes, but we have to cover them again. And of course, I told you that we have to cover these cloud security operations soon because it's bigger topic, so today's episode might be a bit longer. Just bear with me and I'll try to wrap up all the topics of section 5.3 today. And before starting on 5.3, I also will be covering some of the pointers which I missed in the last week episode. When I was going through the previous episode recording and editing that, I realized that there are a couple of pointers which I missed, so I'll share that as well. Let's take a quick short break and then we will come up and we'll start with our today's week episode. Alright, welcome back. So for the missed pointers which I told you about, one of the pointer is around the high availability calculation. So remember, I told you that there is always a requirement of having a high availability. You should have high availability on application level. Your application should not go down. We create this kind of like clustered host where different hosts have applications or have virtual machines spread across, and if one of the VM goes down, either due to a maintenance window or either due to some kind of outage, you still have that application running on some other virtual machine. So high availability is pretty straightforward. The point which I missed last time was the calculation around that. So we normally calculate it around number of nines. So we have this denomination like 4 nines, 5 nines, which ultimately means 99.999 or 99.9. The higher the number, of course, if you have like 5 9 6 9, that means of course it's more available and it have more resiliency. So it's around that. Another pointer which I missed is around SLAs. SLAs is nothing but service level agreement, where we actually have this kind of agreement with a cloud service provider or with the end users that your application will be always running for this much duration, and if it's down, for example, in whole year, if it's down for more than 5 hours, then we will be bring that application up within 5 hours, and if we are not able to bring that up within 5 hours, we'll be liable to pay you some kind of fine, or there will be some kind of cost associated with it. So that's SLA or service level agreement. This is just a generic term. It have a lot of course nitties and gritties. You can understand, you can read more about it. If you are already into the tech field, then you must have heard this term again and again. Alright, for today's topic, let's quickly first understand about the access control. Now, access control part, which is via RDP or via SSH, any kind of login which we are doing into the virtual machines or servers, must have some kind of criteria associated with it. I try to divide the whole topic into 4 or 5 questions, so it's easier for us to understand from where we are coming into. So when we talk about access control, we must understand some questionnaires around this. First and foremost is what is being accessed. So when someone is asking what you are trying to access, then answer could be we are trying to access a server, or we are trying to access a virtual machine, we are trying to access an application using a browser window. What you're trying to access defines what kind of access control should be in place. Second is how it's accessed. So if you are accessing it via terminal, if you are accessing it via RDP or remote session, you are accessing via GUI, a browser window. It can be a number of ways how you are accessing your server or your application. Second is where. So from where you're trying to access your application. Are you trying to access it from a remote host or a jump host or a Bastion server, or you're directly opening it from your local laptop, or you're opening it via some browser window or something. So from where you are actually accessing this application. Then we have who. When we talk about who is accessing, it comes again into the role-based access control and attribute-based access control, where we really define who is accessing and what kind of rights or what kind of authority they must be having once they are authenticated to get inside the system, or once they are authenticated to access a server or an application. And last is when. So by when we can define, is there some kind of time-based control we want to put in. So for example, if there is some business critical application which you don't want people to log in after office hours, you can of course place those controls. So all these 5 or 6 parameters which I discussed with you makes us easier to define and easier to control the kind of access we want to put in for our servers, for our virtual machines, for our application. Now remember, if you are using a public cloud, you won't be really bothered about server access because you are not really concerned, or you don't even have an access to the physical server. But if you are having a private cloud or you are having a hybrid cloud, then you have some kind of components where you can actually have a physical control. So you have to first get answer of all these 5 different questions, and then you can create a better strategy around access control. Now moving on from this access control bit, we already discussed in last week episode about operating system hardening and how we can create a security hardened system by applying some kind of like baseline configuration. We can disable those application or those processes or those softwares which we don't want to use on our operating system or into our application, and we can have this kind of like baseline configuration and baseline architecture. Let's discuss more into the patch management side now. When you have a baseline configuration and there is a recommendation of a particular vulnerability, maybe there is a security operations team or there is a security scanner tool which tells you that your application or your particular software is vulnerable because there's some kind of vulnerability into one of the process. Maybe you are using the older version of a code. So you can have different scenario where you have this vulnerability assessment failed for your server or your application, and what you have to do is you have to apply some kind of patches in that scenario. Now this patching itself have different phases, of course. First is where you detect the actual vulnerabilities, and next the patch release for that vulnerability. For example, if you have one of the software which is running on older code, or if you have some kind of vulnerability where people can actually have sudo access without even having sudo rights, you need to apply patch for that. You need to maybe upgrade it to the next release, or maybe you have to disable that particular function. All these different ways to fix that vulnerability comes under the patch release. But of course, you cannot apply your patch right away. You have to first assess what will be impact of it, because if you straight away start upgrading your processes or your softwares or your application, you might break few things. People might not have the same kind of end user experience which they used to have. There might be some kind of compatibility issues as well. If your application is actually integrated with another application and you upgrade it without checking the compatibility metrics between the other components, then it might break few things as well. And now because we are moving more into this microservices world where we have different tiny microservices working on different containers or different pods, you have to make sure that all applications are compatible with each other. So you cannot just upgrade them right away without just thinking whether they are really compatible. So you need some kind of testing as well before applying the patch. And of course, last but not least, you need to get approval before applying the patch and verify everything is tested, everything is working as expected once the patch is applied. And it really makes sense if you have some kind of automation around this whole patching process. So for example, in case of Windows, you can push the patches via GPOs, or you can have this WSUS system, which is WSUS. I actually forgot what it stands for, but yeah, there is a WSUS system which is responsible for patching your Windows system. For Linux, we can use our own open source tools like Ansible or Chef. So we have a lot of options to automate this whole stuff, because of course it doesn't make sense to do everything manually if you have finally into the phase where you know what you're trying to upgrade, but your estate is having 100 or 150 virtual machines or 50 or 60 servers. You cannot just manually log in and do everything on your own. So it makes sense to have some kind of automation around that. Next is monitoring. Now, monitoring itself is of course quite relevant in any kind of infrastructure, be it cloud, be it older way of legacy enterprise infrastructure. We always need in monitoring. Monitoring itself can be around performance monitoring, where we check whether we have any kind of packet drops, bad IOPS between the storage and between the server. There is monitoring around capacity as well, where we keep checking that our RAM or memory utilization is in control. And remember, we talked about this in the last week episode where we discussed about clustered host, which makes sure that our capacity utilization is spread across different servers. So we have some kind of a balance if we have multiple applications running onto different servers and different physical infrastructure. Using cluster host, we can create kind of pool of all the resources, and we can actually manage the utilization bit as well. Monitoring all these different KPIs or different criteria help us to keep our whole estate, including application, including virtual machines, the whole estate healthy, and keep whole estate in a better situation where we are avoiding any sort of like unexpected event. And in case of critical event, we can recover it as soon as we observe that indeed something is going down. Even we can have this like proactive approach where we observe the behavior of the application and our servers, and we can have this kind of trend where we can observe and understand that something is going wrong with the system. So monitoring, of course, plays a critical role. When I'm talking about monitoring, it's not really about only applications or software monitoring, it's really about hardware monitoring as well. So we have to keep check on our those physical components like fan modules, processor, physical RAM. They should be always up as well. They need to be monitored as well. Now, of course, we cannot keep everything healthy and keep everything up always. These are indeed a physical infrastructure. These are actually a physical components. Even your laptop, your mobile phones, they also go down now and then, right? So it's really no brainer that your physical infra can also go down. And in that case, we of course need backup and restore. So we have to keep our backup. We have to keep all the critical files into a remote location so that we can restore it if there is really some issue with the existing server. We can have different kind of strategies around that. We can take only the backup of the files. We can even take the snapshot of our application, which is more common in case of cloud-based infrastructure where we have this virtual machine snapshot, or more in terms of like software level, then normally we have this database backups or configuration backups where we only keep the file level copy of the real database or the real configuration, and we try to store it in the some other location. We of course have to test them now and then, because maybe the strategies which you put in place, maybe the file you are actually backing up, if you are really trying to restore them in event of some kind of outage, maybe they will not come up as expected. So you need some kind of frequent testing around that as well, so you always have an idea, and you can also of course estimate the real downtime and how much time it takes you to recover the application. So frequent backup and restore testing of course makes sense in that scenario. Just bear with me if you feel that I'm actually going through these topics quite fast than normal, because I know some of the topics are actually repetitive. We have covered them again and again, so it really doesn't make sense to go into detail in this particular domain. So that's why I'm trying to just skimming through the whole chapter and just covering all the subtopics of this section 5.3. Now, for network security control, we have discussed different strategies around segmentation. We have discussed about firewalls as well. One of the topic which we haven't covered in much detail so far is around IDS and IPS, where we have intrusion detection system and intrusion prevention system. IDS is nothing but a solution where you actually detect if there is some kind of discrepancy or some kind of abnormal behavior which is ongoing into the network. Then this kind of IDS solution can easily detect those, and of course they can trigger the alarm. You can have network based IDS solution which are actually put onto the network layer. So maybe they can be put on some firewall interface, or maybe on the router interface as well. We also can have endpoint IDS solutions where endpoint agents are deployed onto actual laptops or physical servers. So anyone who is trying to send data from those server or from those laptop will be triggered right away. So we have different ways of deploying the whole solution. IPS is more advanced form of IDS where we actually have a real blocker as well. The data can be blocked right away if someone is trying to send data from a local machine onto the remote host, which is different from the normal behavior. Then IPS system will actually block that traffic. Now this is of course quite cumbersome. If you have it frequently and if you have a lot of false positives, then maybe the real users will be impacted. Maybe there is actual genuine traffic which will be blocked. So of course you need to optimize these rules again and again. If you are using some kind of AI based models and your solution is claiming that it is self-learning model and it will detect the behavior on its own, you still need to do some kind of analysis and fine-tune those, because if you have more false positive, that means the real users will not be able to send data outside. Another strategy around network security control is use of honeypots. Honeypots are nothing but some physical servers which are created just for the sake of getting attacked. It sounds funny, but they are actually created, they are actually configured with some kind of fake or some kind of irrelevant data related to your company or your organization, and that data is actually put in place on those servers. And they are just lying around inviting the hackers or inviting the bad malicious users to try to get into those systems. It of course helps in detecting if there is really some bad users who are trying to get into your organization. And if you see any activities on those honeypots, that mean of course someone is actually trying to get into your organization. Now way it sound like this honeypot is actually not onto your real company or production network. It will be into a completely different segment. So even if someone is trying to attack it, they will not be able to travel traverse from your one network to another network. It will be a completely separate network with its own server and with its own configuration. So it's kind of like just sitting around and just helping your organization to detect whether there is really something bad ongoing. We have already talked about vulnerabilities and patching and how we can have this kind of like elaborate plan around patch management. Another pointer around vulnerability assessment which I missed during discussing that is vulnerability assessment actually provides a good comprehensive report about your organization and about your systems which are deployed onto your cloud or onto the physical infrastructure. Because now and then, if you are that kind of organization which have some kind of offering which you are selling to your end users and customers, maybe they will be also interested in knowing what kind of vulnerabilities are there into your system or what kind of fix you have applied into your system, because their security team might come up with some kind of recommendation, some kind of CVE number, and they can come up to your security team that we are worried about this particular vulnerability. Is your end system have this vulnerability as well? Using that report, of course, you can showcase that you are completely fix and patch around that. So vulnerability assessment help not only internally to fix everything for you, of course it help in selling the application to end users as well. If you have this kind of like comprehensive list with all the vulnerabilities and what kind of fix you have applied for that. Now, last topic of this subsection or subtopic of this whole cloud security operations domain which I'm covering today is management and orchestration. Now, management is nothing but having a management plane or control plane. We have covered around this in our storage and network controllers discussion, where I told you that we normally keep a separate controller which manages everything, be it a network controller, be it a storage controller. We also have cloud controllers as well, which control and operate all the compute powers from a single machine. But the management plane or control plane which I'm discussing today is around the network which is used to communicate with all these different components. It's always recommended to have a different control plane and a user plane. User plane should be completely around the real data which is going in and out, and control plane or management plane will only be dealing with traffic which is used to control all the components. So management plane or control plane, it's quite pretty normal today. Means all the applications, be it cloud based, be it virtual machines, servers, storages, they all have this segregation. And if it's not part of your application architecture, if it's not part of your system design, then go for it, create that, because we should have these planes or these two type of networks, two type of user traffics on different segments, on different interfaces. Orchestration is around automating most of the stuff, because if you have an estate where you are building, or if even have an application which have multiple virtual machines, then it makes sense to have all those virtual machine kind of orchestrated or kind of created as part of a single stack or as part of a single workflow. So orchestration is building, creating, managing, and even destroying your application, your virtual machines, your containers, part of a single stack, part of a single workflow, and do it in a single goes, because it's much easier to clean up. Once your application is used and it serves its purpose, you can clean it up easily. If you want to apply some kind of patch, you can apply that patch easily as well. So orchestration, of course, makes sense to use it in your day-to-day cloud security operations. All right, that's it for today's episode. I tried to skim through all different components of this subtopic of cloud security operations, which is, I think it's named physical and logical infra control. I tried to cover most of the topics around that. In the next week episode, of course, we'll be continuing into the section 5.4 of this domain. I'll be gathering more information for that and sharing with you all. Let me just quickly open up the syllabus and see what and all we will be covering. So next will be more around operational controls and standards. So it will be topics like change management, ISM, incident management. I don't think those will be that much interesting, at least for me. But yeah, I'll try to read them through, and I will of course share everything around that. So like I said, so next week we will be wrapping up that subtopic of this domain, so we can slowly progress towards finishing this whole cloud security operations. Alright, I will not take more of your time, because of course it's Christmas period and it's holiday period, and if you are still listening to me, then come on, get a life. I also have some life. My pizza and my beer is waiting for me inside the house. I'm just heading out there. You guys have fun and enjoy the day. Goodbye and good luck.
Thank you for listening to Get Certified Together. If you loved our content, then please like and subscribe from your favorite podcast platform, so you don't miss the notification for our next episodes and announcements.
If you're a podcast host, listen up, this one's for you. My name is Allie Jackson. I'm the host of Finding Mr. Height, a dating and relationship podcast that I've been doing for 4 years now, sharing my positive and practical approach to dating that's built on my own life experience. And I wanted to share another experience that I've had, my secret behind monetizing my show. It's called Red Circle, and I was just telling my colleague about how much I love their platform. With Red Circle, not only am I getting a seamless hosting experience, but I also love the support I receive in ad sales. It's not just typical ad sales either. It's targeted opportunities based on my show and my life. And the platform is super simple. You just set your preferences and Red Circle matches you with sponsors that align with your show. You can vet every opportunity and their platform gives you great analytics. More recently too, my Red Circle team has brought me opportunities outside of my podcast on social media to really augment the podcast partnerships, bring them full circle. I just can't recommend them enough. If you want to give it a try, go to redcircle.com to get your free trial. That's redcircle.com for a free trial.